All right, basic properties. Well, we said at the beginning the domain of sine is going to be negative pi halves to pi halves. And this, by the way, is, the range of the inverse sine, arc sine. Why is it the range? Because it's always the case. The domain of the function is the range of the inverse function, always. Similarly, the range of sine we know is negative 1 to 1, and that must be the domain of the inverse sine, arc sine of x. Okay. On a similar note, when you compose sine with its inverse function, I wrote it this way, but I could have just as easily said arc sine right here. When you compose them, you get out x so long as x is in the domain of the inside. The domain of the inside is right here. So these compose together if x is between minus 1 and 1. And it turns out this is an important restriction. We're going to see some examples of this in a minute. Similarly, this composition is x if x is in the domain of the inside function, which means that x has to be between minus pi halves and pi halves. Okay, one other thing that I'll just go ahead and say is the arc sine of x equals y if and only if, right? Think with me. Let me erase this part. Whoops. If and only if, well, arc sine, inverse sine, is mapping x to y. That means sine maps y back to x. I've tried to repeatedly say this is the one thing you need to know about inverse functions to be able to work with them. So we've got all these basic properties. Here's another thing. So here's the graph of sine. I've tried to sketch, this is all just a rough hand sketch, but sketch y equals x, and you flip the graph of sine over that line, you rotate it, and let me see if I can do it here. You're going to get something like this. It's going to come down and then go up a little steeper and then come down and go up steeper like that. Something that looks like that. And so here's my sketch. This blue one, the blue one here is, oops, I should write in blue so you can keep track of it. The blue graph is sine of x, and then the red graph was my rough attempt at arc sine of x. And of course, here's a better graph of arc sine of x. Yeah, I've already labeled it, so I'll just erase that. Okay, so there's the basic properties, there's the graphs. Let's do some quick examples. So this example, we're asked to simplify these problems. So inverse sine of the sine of 1, you just want to check that 1 is in the domain of sine. Well, it is, because 1 is between minus pi halves and pi halves. So this composes to just 1, since you know that 1 is between minus pi halves and pi halves. That has to, whatever you plug in here, if you're going to compose this and just say that it's the same thing, then whatever's in here has to be between minus pi halves and pi halves. Okay, on a similar note, sine of arc sine of 1/2, this composes just to a half, because now 1/2 is in the domain of arc sine, right? 1/2 is between minus 1 and 1, the domain of the inside function arc sine. So here's an example where you can't just compose. So I want you to realize this is not equal to 2 pi. Why not? Well, that's because 2 pi is too big. It's not in the domain of the sine of x, which is equal to minus pi halves to pi halves. Now, there's a trick you can do in this case. You happen to know that the sine of 2 pi is 0, and the sine of 2 pi is exactly the same as the sine of 0. And so this is equal to the inverse sine of the sine of 0, and that is just 0, because 0 is in the domain of the inside function sine of x. All right, for this last example, I want us to simplify this expression, and this is a trick you're going to need in many different situations in calculus, here in Calc 1 in this section, but you'll also use it in Calc 2 as well. Just comes in handy. So I want you to name this inverse sine of 4/5. Call it something. I usually call it theta, because actually you can think about the inverse sine of something as an angle. So I set it equal to an angle theta. I know that inverse sine maps 4/5 to theta, if and only if sine of theta equals 4/5. And now I need you to realize anytime you have a trig function of an angle equals to something like this, you can always draw an associated triangle. So draw your triangle. There's theta. Sine is opposite over hypotenuse. And so you can use the Pythagorean theorem to fill in this side, and you get 3. And now you say, wait a minute. Tangent of the inverse sine of 4/5 is the same thing as tangent. We called this theta. So this is just tangent of theta, but I have this picture that represents theta as well. And so tangent of theta is just opposite over adjacent, which is equal to 4/3. And so that's how you can simplify that. Okay, so we'll stop here.